Hey guys, today we are going to talk and start a unit on factoring. Now factoring is arguably the most important thing you do in an algebra class. It's really useful in higher levels of mathematics, and you'll be used a lot in your futures. So we really want to make sure that we're okay with how to factor things out. So factoring is, it's the process of taking or given an expression, figuring out what was multiplied together to equal that expression. And there's a lot of different patterns we look for, there's a lot of different methods, and knowing certain patterns is really going to be useful for us here. And to break it down just to a really basic example, let's say we have the number 6, and we wanted to know what times what equals 6. Well, we could say 2 times 3. So this would be the factors of 6. 2 times 3 will equal 6 for you. Notice how we can't factor anything out of these two. There's no more, if we do the prime factorization, we can't go any further down. Each one of these numbers is prime. Let's say we were factoring out, let's do the number 20. And let's say we said, well, for 20, you could do 4 times 5. But we could go even further, because 4, well, there's factors of 4. You could say it's 2 times 2 times 5. And that's the prime factorization. So our goal now, instead of doing this with a 20 or a 6, is to do it with an expression, a polynomial, where we have those variables involved as well. Now there's a lot of different methods, and we're going to be looking for a lot of different patterns. So the first method we're going to look at, and it's going to be the method you should always start with, is GCF. Find a greatest common factor. So the first example that we have on here, we have 2w squared plus 6w. So between your terms, to find the greatest common factor, well, you're going to look at the coefficients and say, do they have anything in common? Does 2 and 6, do those two numbers have anything in common? And, well, they have a 2 in common. So we're going to factor out a 2. For now, I'm just going to say the GCF is going to be, they both have a 2 in common. And now we look to the variables. This term has w squared, so it has w times w. This term has just a w. So in common, they have 1w. So the GCF would be 2w here. Now how it works to factor it out, it's like the opposite of distributing. You're going to say what was multiplied together to get here. So you take your GCF, and what would you have multiplied 2w by to get 2w squared? Well, you'd multiply it by a w. 2w times w would equal 2w squared, and you would multiply 2w by 3 to get 6. So that's why we say we're factoring it out. We're taking out the greatest common factor of both terms, but we would end up distributing it here to get back there. So this would be the factored version of this. After we factored, we ended up here. And this is how we can use the GCF. Okay, so let's go ahead and try our next example. We have 27 y squared plus 18y, and we need to figure out a GCF first. And if you look for a GCF, look at your coefficients first. 27 and 18, do they have any factors in common? And you want to find the greatest common factor. So you might notice they both have 3's in common, but hopefully we get to they both have 9's in common. They both have a 9 in common here. So you're going to factor out a 9. You have a y squared and you have a y. They have just one y in common. So we're going to have 9y, that's your GCF. And then what would you multiply it by? So if you can't kind of figure it out in your head at first, you can divide your terms. Divide this term by 9y. 27 divided by 9 is 3. Y squared divided by y is y. So you would have multiplied by 3y. 9y times 3y would give you 27y. So if you're having trouble figuring out these terms, you really could just divide by your greatest common factor. 18y divided by 9y, well, that would just equal 2. So 9y times 2 would give you 18y. And here you are, all completed. So this is the factored version of this. If we were to distribute the 9y throughout, we'd end up here. Okay, now let's see. And actually for this one, I mentioned in the beginning, you might have noticed the 3 in common. if you were to have taken out a 3, you didn't take out the greatest common factor, but you did take out a factor, you would end up with, well, 3y, and then you'd have 9y inside plus 6. And then if you look at these two terms, you're going to notice they still have something in common. They both have a 3 again, so you would take out another 3, and it would be 3 times 3y, and then you took out the 3, so you'd have this right here, and you would do 3 times 3y is 9y. But finding the greatest common factor first is going to save you the steps in the end. Now, on to our next example. We have 4y to the 5th minus 6y to the 3rd plus 14y squared. Alright, so let's find the GCF. And as you get better with these, you don't have to list what the GCF is. You'll start taking that really quick. But look at your coefficients. Well, in common, looks like they all have a 2. So we're going to have a 2 that's going to be factored out. Looking at your y's, we have 5 y's being multiplied here. You're going to have 3 y's being multiplied. You're going to have 2 y's being multiplied. So all of them have at least 2 y's being multiplied. So we're going to factor out a 2y squared. Here, if you you take out your 2y squared, you'll end up with 2y to the 3rd. If you multiply out, you would have 4y to the 5th. Now here, when you take out your 2y squared, you're going to be left with minus 3y. 2 times 3 gives you the 6. Y to the 2nd, you're going to add the exponents, you would end up with y to the 3rd. And your last one, you're going to have plus. If you take out 2y squared, you factor that out, you're left with just a 7. 2y squared times 7 would give you the 14y squared. So this would be after we factor. Alright, we're going to try one more, and then you'll have 2 to try on your own that you can check with me. Alright, so our next one, we have negative 12 a to the 2nd b minus 9a b to the 2nd plus 6ab. I'm going to keep listing the GCF, but again, as you get better with these, you'll do them a little quicker. So you might notice in common here, we have a 3. We have a 3 in common. And now we have 2 variables for each term. Notice that they all have an a and a b. We have an a squared here. We only have 1a. We only have 1a. So everyone has at least 1a. Here we have a b squared, and 1b. So everyone has at least 1b. And then we're going to go ahead and factor that out. So the 3ab has been factored out, the greatest common factor. So what would you multiply 3ab by to get here? Well, that would be negative 4, then a. And if you notice you multiply these two, you get negative 12 a squared times b. Now if you go ahead and go on to your second term, minus 9ab squared, well, if you multiply this, it would be minus 3, and then b. If you distribute your 3ab to negative 3b, you'd end up here. And your last one, if we factor out the 3ab, you're left with plus 2. So there we go. We are completely factored there. So one other thing to keep in mind with this particular problem too. Let's say this last term didn't have the b. Then we're finding the GCF. We're going to have the 3 still, but we're not going to be able to incorporate the b, so it would just be 3a if there was no b there. So every term has to have everything in common. It's the greatest common factor of all the terms. And if there was no greatest common factor, if it looked like this, and we can't factor anything out, and it's not factorable, then we would just call it prime. It would be a prime polynomial then. Okay. So last 2 that you're going to try, using the GCF here. And again, whenever you're factoring, you should start with the GCF. Look for a GCF first, because if you don't take it out first, in the end it's going to come back and it'll still show up somewhere. So here's the 2 you can try on your own. If you want to pause and give them a go on your own, that's fine. I'll go through both of them right now. 9gh squared minus g squared h. So for the first one, over to the left, the coefficients, there's nothing in common. So in your GCF, you're not going to have, your coefficient is really 1, but there's no coefficient in common there. No factors in common. But if we look at the g's, we have a g squared, we have a g, we have a g squared. Everyone has at least 1 g, And if you look, everyone has at least one h, so we can factor that out. So we'd be factoring out g times h. For your 10g squared h squared, you'd be left with 10gh, because if you were to distribute this monomial in, you would end up right here. For your middle term, you're going to have 9. Well, you took the g out. You took one of the h's out, so you have 9h left. And then for your last term, you took one of the g's out, so you're left with a g. You had 2. And you took one of the h's out, so it's gone. It's out here now. And then this is your final factored form of this. We are completely factored there. Took the GCF out. Alright, our last one is this red one over here. We have 21b minus 15ab plus 42. So if you're looking for greatest common factor, start with your coefficients. Let's see some of the factors of 21, 7, and 3. 7 works for the first and the last, but not the middle. But 3 works for all of them, so there's going to be a 3 in common. We have a b here and a b here, but not a b here, so we can't factor a b out. We have an a here, but nowhere else, so we can't factor an a out. So our greatest common factor here is simply 3. So you factor out a 3. You would have to do 7b, because 3 times 7b would be 21b. Then you would have minus, we factored out a 3, so it would be 5ab. 3 times 5ab would give you negative 15ab there, minus 5. And then you have the plus 42, but you factored out a 3, so you should end up with 14. And here you go, now we're completely factored. Alright, and we're all done. So that's how you can use the GCF. Again, when you're going to go through, you're going to learn plenty of other methods, and you're going to be looking for other patterns, but the GCF is the first one you should look for. Take out a GCF, and then you'll look for other patterns that you might recognize. Alright guys, have a nice day.